Alright guys, I'm going to do number 34 next. So 34 is the sled being pulled at a constant velocity. That might be something you missed there. When it says constant velocity, that tells us something. So V is constant. I'm just going to make note of that because that is useful information here. Force is 8.0 times 10 to the first newtons at an angle of 53 degrees to the ground. What is the magnitude of the friction, basically? So frictional force, and it's going to be kinetic force because you're moving, equals what? So let's draw our picture. We have the sled is on a horizontal surface. Again, my sled is not super pretty here, but we are going to have, so again, it's being pulled at a constant velocity on a horizontal surface. So V is going to be in this direction, but it's constant. Remember, V is constant. That means, let's say you are going at 12 meters per second. You're going 12 meters per second here and here and here and here the whole time you're traveling at 12 meters per second. So what does that tell you about acceleration? If velocity is constant, acceleration is 0. So that probably was all you needed, because now it's just a simple Newton's second law problem. Okay, so if we do Newton's second law, and remember that the summation of the forces in this x direction is going to be equal to mass times acceleration. So it says we've got this force, pull. Force pull is equal to 80 newtons. Notice that you have two sig figs though. And the angle, that's kind of cool. I should be playing with the tools while I do this though. So this theta is equal to 53 degrees. And again, the reason that is because we have to find our force pull in the y, and our force pull in the x. Okay, so the force pull in the x is going to be my adjacent, and the force pull in my y is my opposite for SOHCAHTOA. So again, remember SOHCAHTOA. So for my adjacent, I'm going to do cosine theta is equal to adjacent over hypotenuse. So for my force pull in the x is going to be equal to, I'm going to do cosine of 53 degrees is equal to force pull in the x over the hypotenuse, which is 80 newtons. So cosine 53 times 80. So force pull in the x with two sig figs is 48 newtons. Yes, we do. There's only 10?
Yeah.
You sure?
Yeah.
I think I ordered. I'll come look in a minute. I must have ordered it twice. I'll go check. Okay. 48 newtons. So then we have to do sine of 53 degrees is equal to force pull in the y over 80 newtons. So sine of 53 times 80. And I get force pull in the y is equal to 64 newtons. Again, two sig figs. So force pull in the y is 64 newtons. Force pull in the x is 48 newtons. Always double check these. It's really, really easy to get your y and your x mixed around. Okay, so now if we sum our forces in the x, we know we're also going to have this frictional force. And this is what we're actually solving for, is what is this kinetic friction? The only forces acting in the x direction are going to be the force pull in the x and the friction force. So I'm going to come over here and redo this. So summation of forces in the x are equal to mass times acceleration. So I'm going to have my force pull in the x, which is 48 newtons, minus, or you can add a negative, because again, friction is going the opposite direction. So this frictional force is equal to my mass times acceleration. I don't know mass, right? And that might have thrown some of you off. But remember, if acceleration is actually 0, does it matter what mass is? No, that is 0. So let's keep solving. We've got 48 newtons. A lot of you might see it already. Is equal to 0. So if we add the friction force to both sides, we get the 48 newtons is equal to the frictional force. Remember, this negative sign assumed that you would remember that this is to the left. So if you were just describing this force, you might say a negative 48 newtons or 48 newtons to the left. That would be the answer.